The producers of Tech AV Technical Training Aids welcome you to this program on the topic of oxyacetylene downstream equipment. In this module, we shall describe and demonstrate procedures concerning gas welding torches. We shall be looking at two popular types of welding torches, namely the balanced pressure torch and the injector torch. All gas welding torches share certain features, namely a stock or handle section, gas control valves or torch valves, a gas mixing section, and a nozzle or tip. This is a typical balanced pressure torch, also known as an equal pressure torch, and sometimes referred to as a high pressure torch. This torch requires both the oxygen and the fuel gas, acetylene, to be delivered at equal pressure, usually around 60 kilopascals, in order for the gases to flow and to mix in the correct proportions within the mixing unit. In contrast, an injector torch, which is also known as a low-pressure torch, operates with low-pressure fuel gas. It is the oxygen flow, set at a much higher pressure, typically at 60 kPa, that causes the acetylene to be drawn, by suction, into the oxygen stream. This is achieved through the Venturi design of the mixer unit. A few points to keep in mind when assembling your balanced pressure torch will be demonstrated. Balanced pressure torches comprise three basic renewable components, namely the stock, the mixing unit, and the nozzle. Assembly begins with the mixing unit being attached to the stock. Do this carefully in order that the inner components align before you engage it with a firm push. Thread the retainer nut onto the stock threads, but at this time do not tighten it firmly. Next, select the specified nozzle or tip and simply thread this loosely into the mixer tube. Orient the stock or handle in such a way that the valves are positioned to the bottom, and then secure the mixer and the nozzle in such a way that the torch is oriented at a comfortable angle. Use only correctly fitting spanners, not pliers or adjustable spanners, to secure the retainers. The nozzle requires hand tightening only. Assembly of an injector torch is even simpler, but we need to be aware of some important facts. The most important aspect of this task is to make sure that the mixer unit's O-ring seal is in place and that it is in good physical condition. Any damage to this sealing device will render the torch unusable. Insert the mixer carefully so as not to cause damage to the O-ring as you push the unit firmly into the stock. Next, install the mixer retainer nut, making sure that it is the right way round, and engage it onto the stock threads. Before tightening the retainer nut, align the nozzle tip to the position that you want it. Secure the retainer firmly using a correctly fitting spanner. And that's all there is to assembling your injector torch. We have now seen the important features of two popular types of welding torch. We must, however, mention that no matter which type you select, make sure that the torch meets with International Standard ISO 5172 or your local equivalent. Welding nozzles of both balanced pressure and injector torches feature a single orifice. This is essentially a drilling of precise size. The size, or diameter, of an orifice determines the amount of gas that will flow to the flame when the regulator pressures have been set correctly. Gas flow through the orifice ultimately determines how much heat will be available to put into the metal. Nozzles designed for balanced pressure torches each display a nozzle number. This number indicates, in cubic feet per hour, the gas flow through the orifice when gas pressures are correctly adjusted. Nozzles, or tips, designed for use with injector torches, simply offer the orifice size, and this size must match the information displayed on the mixer body. Unlike the equal pressure torch, you will need to fit the complete mixer unit whenever you change the nozzle size.